Okay, today we're going to be working on the cheat sheet, getting ready, reviewing to get ready for the Unit 2 lab exam. So to find, this is my answer key for the first one we're going to work on, which is 4.2 one sample t-test. But to find the blank one that you guys will be working on, go into Canvas, go to your chapter 4 through 6 banner. You want to be on chapter 6, and I put all of your review materials right here above Unit 2 lab exam. So go ahead and click on cheat sheet, and you want to make yourself a copy. And so I would recommend you go in and you name it, instead of copy of, maybe put your initials in the front or put your first name, something so that you can see that it is your version of the cheat sheet. So we'll be working together to fill in 4.2 one sample t-test. One thing that I did to kind of change mine a little bit is I made another cell here where I could put the code for the R homework. So if you want to make this two separate cells here, what you want to do is highlight and then just that cell, nothing else is highlighted, and then you're going to right click and then split cell. And so I want it to stay one column, but I want it to be 2 rows. And hopefully it'll match up with this code line here. And then when you get ready to go do your R homework, whatever code you use to complete the R homework, you can add that in here. So that's just one thing I added in after the fact, and I actually did a part 1 and a part 2 for the R homework 4. The R homework has a part 2 that goes more aligned with 4.3. So the first half of the assignment goes with 4.2, and then the second half goes with 4.3. So you might want to separate your code that way. So it's relative to everything that's there. But anyway, I'm going to work through this research question with you. This is the level 2 lab. You guys should have already done this high school lab. So to fill in your writing assignment here, your histograms, or I guess this one would be a single histogram, and then the code that you use, you're just going to go into your high school lab from 4.2 and you're going to just copy and paste your paragraph, graph, and then your code in here that you used. But we're going to fill in the research question. So in RStudio, you should definitely start out with your RStudio all cleaned up. Mine should be. I think I did that before I started making the video. So sweep your environment, make sure you have no files open. Go ahead and exit out any tabs you have. Sweep your console. If you have any plots, make sure you sweep those. And then under files, we should just be under the project window so that we have all our folders showing. And I always like to start with a blank script window. So I just did the plus sign up here and selected the first option. Okay, so our question that we're working on first is here. Remember, we want to put hashtags for any comments that we have, so it's not included in our code. So we have the average male in the USA is 70 inches tall. So that's a value that we're testing against. So we have a value that's a good hint to tell you that this would go along with Lab 4.2. The question we're having to answer that we're being asked is, do the bull riders from the USA have an average height that is significantly different than 70 inches? So I actually don't need the sentence because the 70 is in there already. So we can shorten this up a little bit, not to take up so much space. But just remember, in the end, we are testing against the mean, the average height of 70 inches. Okay, so this one is a 4.2 question. So I'm going to go to OnRamp scripts, and I am going to use 4.2 as a guide. It does appear that there's a lot going on here, but I'm going to go ahead and copy it over. I like to copy it over and clean it in my script window instead of cleaning it within the script. You don't want to mess up your script. I also don't ever try to see the first few rows of our file. But anyway, I'm going to get everything after that and paste it in. And then I'm going to kind of clean it up. So we'll probably have to do a subset. We'll look at that in a minute. We are going to have to visualize the distribution. It's not going to be a white blood cells, but that's okay. We're going to need to do the center of the distribution. We're going to need to do the spread of the distribution. And then we're going to need to run a one sample t-test. So all of that's going to be good, good to follow, but obviously we're going to have to do some different subsetting and use some different variables. This data set uses the Bullwriter data, so we need to go import that. So up here in our environment, we click on Import Dataset from Text, and we want to be in the OnRamps data folder, and this is Bullwriter. This is one of the files that is not defaulted to be yes, so we do need to change that heading to yes. And I'm going to call the name of the file lowercase bull, B-U-L-L, all lowercase. Okay. Pretty much done with the script that I copied and pasted from. I have everything, so I'm going to go ahead and exit that out. And I'm going to bring my script that I am working with over here. So do the Bullwriters from the USA. So we need to create a subset of just the USA Bullwriters. So create a subset of USA Bullwriters. So let's think that out a minute. In the Bullwriter data, you can see country, and you do have some USA Bullwriters. Looks like we have some Brazil, some Canada, some Australia possibly, but we only want the USA for country. So the variable we're subsetting out is country, and where it's equal to capital U, capital S, capital A. All right, so let's call this subset that I'm creating lowercase USA. I like to keep the names of things very simple. No capitals, no crazy spellings. We are pulling out of the file name bull. So where it says health here, we're going to change both of those to the file name bull. After the $ is always the variable. So we're going to put country, double checking that it is capitalized correctly and spelled correctly. It must match this heading country here perfectly. And it does. So then inside of there we need USA, and it was all capital. We want to keep the comma. It doesn't matter if we have single quotation marks around the USA or if they're double quotation marks. Either way should work for us. So we're going to run that. And notice that we have 37 USA Bullwriters. So we went from 58 down to 37. When you subset, always double check that you actually get observations. If you have 0 observations here, then your subsetting did not work and you need to go back and troubleshoot that. So don't go forward until you make sure you did pull some data out of the Bullwriter data. The other thing you can do is you can hit this little Go spreadsheet over here, and it will pop up and show you that your data does include all the USA Bullwriters. Okay, so we have that to look at if we want to. Now we want to look at the height of those Bullwriters and see if it's different than 70. Keep that in mind. So we want to visualize the distribution, and we always, for numerical data, we use HIST for the histogram. We are done with bull, okay? The data that we're graphing is the USA only. That USA file is what we're graphing, finding the center of, finding the spread of, running the test on. Once we've subsetted out USA, we're really done with the bull file. Okay, the variable we want to visualize is the height of the Bullwriters. I'm not quite sure if it's capital H or lowercase h. It's capital, so it has to match this heading perfectly, HEIGHT. Okay, so we're going to run that, but before I do that, even they are going to want you to put a title and label your x-axis, like label your graphs appropriately. I always go back to 2.3. I don't know why, but that one seems to be my favorite to go find the labeling system for a histogram. So I'm just going to go copy it after I actually need the comma as well. After their variable, which their variable was days.shelter. All of that will help you if you don't know off the top of your head how to label your histogram. So I'm going to paste that in. So where it's main, that's where your title can go. So our title is the height of USA Bullwriters. And so the X label, I'm not quite sure. I'm thinking it's inches just because the question here, but it is good to know that if you're wondering what the units in your file are, if you go back to project and you look at the keys, data keys, there is a data key for every single one of these files that they have us use. And so if you click on the bull writer and you say view it, it'll tell you the units of measurements for each of the variables used in the data set. So height is measured in inches, as I had guessed. So my X label should be inches instead of days. All right, so height of USA bull riders in inches. Let's run that one, see what we get. Okay, so beautiful. It's approximately normal. It's got a slight gap in it, but not too bad. I would say this one's roughly normal. Okay, so if we're trying to get the appropriate center and spread, since it is roughly normal, we are going to use the mean for the center, and we're going to use the standard deviation for the spread. And so that code or that function for standard deviation is SD. We are going to need USA $height, so I'm going to copy that from above as our file name and our numeric variable. So the average of this graph appears to be 68.486-ish, which does look, you know, that does look reasonable for this graph, that you'd have about 68 in the middle there. We do need the standard deviation to be able to report in our write-up. So we're going to run that, and this one says we have a standard deviation of about 2.36 blah blah blah. Now we're ready to run our t-test. So right where it says the file name $variable, again we need the USA $height, and where it says replace code, we have to put the average value that we're testing against. And so mu is equal to 70 in the question. It did say that we were testing, is it different than 70 inches? So we're going to run that. And so these are the values that we're going to base our conclusion off of, and we're going to base our writing paragraph off of. So we have a test statistic of negative 3.8938. Ignore the degree of freedom if you want. You can report it. There's nothing wrong with that. And it does make sense that it would be 36 since our sample size is 37, because when we run our one sample t-test, our degree of freedom is our sample size minus 1. We have a really small p-value. It is absolutely less than 0.05, so we will be rejecting the null hypothesis. The other thing we can talk about is the confidence interval. Okay, we have a 95% confidence interval given from 67 point blah 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 to 69 point blah blah blah, and so our tested value of 70 is not within that confidence interval. So that also supports the fact that we're rejecting the null hypothesis. So to save a little bit of time, I'm just going to pull up my actual write-up, and we're going to kind of dissect it a little bit. So for 4.2, I have already written my paragraph, and I'm hoping that I did get the same values in RStudio that I had gotten previously, or that I got, you know, what I'm getting right now with you live on the video, I'm hoping is what I got previously when I typed this up. The graph definitely looks the same. Yeah, looks good. The values appear to be the same. So I'm just going to kind of dissect what I have written here and tell you all the pieces that you should be including to answer this question after you've actually run the test. So the first thing you need to talk about in your writing conclusion is which test you're running and why. Why did you choose that? And so you'll look, you know, on your actual lab exam, they're going to give you some options. Either it'll say like do one of these steps 1 through 5, or do one of these steps A through E, however many they give you. And so I would say, okay, I'm going to copy and paste it. I'm going to do one. Oops. I'm going to do the number 1 option, and maybe it was called one sample t-test. I don't know what it's going to look like, you guys. But you're going to have to copy and paste whatever the italicized thing is that you're doing. And this is, I believe, 4.2. Bump over and make sure. Yes, it is 4.2. Okay, so you need to name what test you're doing and why you're doing that test. So I said I chose to run a one sample t-test because there is one group. There is one sample. Okay, I'm not comparing multiple samples. It's just one. of USA Bull Riders, and we're testing their average height. What is the average height? It's a numeric variable. So that is why I'm doing a one sample t-test instead of one of the other options. I have one sample and I have a numeric variable that I'm testing. Okay, so that's the first thing you want to do, is name what you're doing. The second thing you want to do is actually part of the rubric, and it is typically part of the rubric, it's to list all of the assumptions. You have to check random, independent, and is the population normal, or is the sample size sufficiently large? Is it large enough? I have 30 on here. Basically, it just needs to be large enough. A value that was given in some of the videos that we gave was 20, but reasonably, is it large enough? That's what you need to talk about. You don't have to use a specific number here, but you don't want a tiny sample size. So this is me addressing all the assumptions. Okay, so I say, since we are working with provided data, the random assumption may not be met. Proceed with caution. You do need to acknowledge that since we're working with data that's in our studio, we don't know if the bull riders were selected randomly or not. So the next one is, I don't know why I went straight to the sample size there. I don't know if I would have even included that, but you can if you want. Next, I would go to independent though. So it is assumed that the observations were independent. So each of these bull riders are not affecting each other, obviously in height. If I'm a certain height, that doesn't mean that the bull rider standing next to me can't be that same height or whatever they are. When making a histogram, which we have included here at the bottom of our write-up, so when making a histogram of the height of our subset, the histogram was approximately normal and the sample size of 37 is sufficiently large. So just giving that sample size and saying it's big enough is good. Okay, so that's your assumptions paragraph. You definitely need to have that. Another thing you have to give, and guys, I'm just breaking these into separate little paragraphs to make it easier. You can put this all together if you want. I kind of like the broken paragraphs though. So the next thing I talk about is describing the distribution with center and spread. Okay, you need to give the appropriate center and spread. So if our data is approximately normal, then we're going to use the mean and the standard deviation to describe the center and spread. If our distribution is skewed, then we should be giving the median and IQR to represent our center and spread. So that's what I've done there. I said the center of the distribution is at the mean height of 68.48649 inches. And so if we go back to our studio, you can see that I did not make that number up. I got it here. And then my next sentence is going to say that the standard deviation is 2.364337. I don't even think I bothered to round them. I just gave them. Copied and pasted them right out of our studio. If I had time while I was taking the lab exam, I might go clean that up and round it a little bit. But it doesn't matter. You can give the full value if you want. So you do need to attach your unit on there though. So notice I do have inches on those. So the spread of the distribution is the standard deviation of 2.364337 inches. So now I'm making my conclusion, my actual, whether I'm rejecting or failing to reject, and I'm basing it on my test statistic, and I'm basing it on my p-value given in our studio. So my test statistic here, already went over that with you, is that value, and then my p-value is here. So I said, since negative 3.8938 is in the critical region, if you're rejecting, it's going to be in the critical region, and the p-value was about 0, which is less than the significance level of 0.05, we reject the null hypothesis. Now I have to say in context what that actually means. So therefore, there is a significant difference from the height of 70 inches for USA bull riders. I added a little extra here that I don't think they grade for. So you don't have to give it. I'm going to say this is extra, kind of our extra credit if you just, and the reason I say this, guys, is because I saw people on their high school labs even, I don't know, even on y'all's project, instead of giving the test statistic and p-value, you guys wanted to give the confidence interval to make your conclusion. So that would be extra here, but guys, they're going to want to see your test statistic and p-value to back up your confidence interval. So if you want to additionally give the confidence interval, that's great, but don't only give the confidence interval, okay? Let it be extra. So I said additionally, the 95% confidence interval of this number to this number. So again, that's from RStudio. It's right there at the bottom of your t-test after you've run it. Supports the conclusion to reject the null hypothesis. Why? Because that tested value of 70 is not included in the interval. Okay? So that's what you're going to give them for your paragraphs. And again, you don't have to give this fifth one if you don't want to. If you're running out of time, no big deal to leave that confidence interval off. But you do have to say what test you're running and why, what the 3 assumptions. It's typically 3 assumptions except for ANOVA, the random, independent, and then is our sample size large enough? Is our distribution normal? And then you want to report the center and spread, and then you want to give your conclusion, whether you're rejecting or failing to reject, based on your test statistic and your p-value. And then, of course, that second sentence of actually in the context of the scenario, what does that conclusion mean? If you have extra time, give them the confidence interval. Okay, so that is what you should have for 4.2 on your cheat sheet.